Good morning, students. Today we'll discuss about the gaseous state. So as you know, there are three states of matter: solid, liquid and gas. So in class 11 we have to study about the gaseous state and the liquid state, and the solid state you have to study in class 12. So first I'll start the gaseous state. In case of gas, the gases will follow some laws which are called gas laws. First thing you should know about this gas law. For example, Boyle's law, Charles' law, Avogadro's law, Dalton's law. These are the laws of gases, and every gas obeys these laws, and these are called the gas laws. So I have given some gas laws, and one by one we'll do. Number one, Boyle's law. Boyle is the name of scientist. Boyle gave a law which is called Boyle's law. Actually, this law gives the relationship between the volume and the pressure of the gas. So this law gives the relationship between the volume and the pressure of the gas. According to this law, at constant temperature, your temperature should fix, otherwise the law will not be followed by the gases. So at constant temperature, the volume of a definite amount of gas, definite amount of gas means number of moles should be fixed. Definite amount of gas is inversely proportional to the pressure of the gas. Do you know every gas exerts a pressure? And why the gases exert pressure? Whether you keep the gas in balloon or in some container, every gases exert pressure inside the container. Why gases exert pressure? As you know, gas molecules have no force of attraction, and due to which the molecules can move freely inside the container. And when they are moving inside the container, the molecules can collide with each other, and they can collide with the walls of the container also. Actually, number of collisions takes place inside the container, and due to this collision, they exert a pressure which is called the gas pressure. So whether you keep in balloon or in some other container, you will get some amount of pressure inside the container. So what about this law? Suppose this is a container, and the container contain a gas. This is your gas. Now let the volume of the gas is 1 liter. You know, gas do not have any definite volume. What is the volume of the container? That is the volume of the gas. So suppose the volume of the gas is 1 liter, and temperature I have considered as constant. I mean, it is fixed. There will be no change of temperature. Now if you apply pressure inside the gas by applying some piston or some other appliances, when you apply the pressure, then what happens? When you apply pressure, the volume of the gas is going on decreasing, and that you have written at constant temperature, the volume of a definite amount of gas is inversely proportional to pressure of the gas. If you apply more pressure, volume going on decreasing, and if pressure is reduced, volume going on increasing. So volume and pressure both are inversely proportional to each other. You know, in case of gas, normally the volume is represented by V symbol, pressure is represented by P symbol, temperature is represented by T symbol. So symbolically, if you want to represent the law, then you can write V is inversely proportional to pressure. I mean volume is inversely proportional to pressure. If pressure is more, volume is less. If pressure less, volume will be more. But this law is applicable only when the temperature and the number of moles N is constant. Otherwise, law is not applicable. So V proportional 1 by P, this represents the Boyle's law. Volume is inversely proportional to pressure at constant temperature and number of moles. When you remove the proportional sign, then a constant will come K into 1 by P. If you take P this side, then PV is equal, you can write K. So what is the meaning of this? P means pressure, V means volume. The product of the multiplication of pressure and volume always constant. The meaning of this one is, for example, PV is equal K. What is the meaning? Let the pressure is 100 atmosphere and the volume is 200 liter. So what about the value of K? After multiplication, you will get 20,000. Okay. Now, if you change the pressure, I mean if you increase the pressure, suppose from 100 you increase the pressure up to 200. So how much you increase? You make it double. So when you increase the pressure, then volume automatically going on decreasing. And you increase the pressure double now, so volume will reduce to half. I mean it becomes 100. So what about the multiplication? It will remain same. So that is called K. I mean the product of pressure and volume always constant. It is fixed. So you can increase the pressure, you can decrease the pressure, but the product of pressure and volume always constant. That is called PV is equal K. Now let you change the pressure from P to P1. You change the pressure. When pressure changes, volume also changes. Suppose volume changes to V1. But what about the product? Product remains same. That's why you have to write K. Don't write K1. Similarly, from P1 you change the pressure up to P2. When you change the pressure, volume automatically going on changing, it becomes V2. So this is also equal K. That means you can write P1 V1 is equal P2 V2. This is according to Boyle's law. So this relation you should know, and from this relation you have to do the numericals. So what was Boyle's law? Boyle's law gives the relationship between the volume of the gas and the pressure of the gas. According to Boyle's law, the volume of a definite amount of gas is inversely proportional to the pressure of the gas, which you can write V proportional 1 by P. And when you remove the proportional sign, a constant will come. After that, you will get the relation P1 V1 is equal P2 V2. Now, according to this Boyle's law, if you want to plot pressure versus volume, this side pressure increases, this side volume increases. Since both are inversely proportional, when pressure is more, volume will be less, and when pressure decreases, volume going on increasing like this. So this type of curve you will get when you plot P versus V, I mean pressure versus volume, plot you will get like this. Similarly, if you want to plot PV versus P, I mean this side PV going on increasing, this side pressure going on increasing. As you know, PV is always constant. You can increase the pressure, but the value of PV always remain same. That is why here you don't get any sense. You will get this type of line. I mean the value will remain same. You can increase the pressure, but the product of pressure and volume always constant. So this type of plot you have to know. Now, what type of question will ask? For example, this is a container, and the container contain a gas. The volume of the gas is found to be 500 decimeter cube. Decimeter cube means liter. I mean 500 liter. And suppose the pressure of the gas is 1 bar. I mean when the volume of the gas is 500 liter, the pressure of the gas is found to be 1 bar. And temperature is fixed, that is 30 seconds. Now, if you want to reduce the volume from 500 to 200 dm cube, initially it was 500 liter, now you want to reduce the volume up to 200 liter. So what you have to do, you have to apply some amount of pressure. So how much pressure you have to apply to the gas so that the volume will reduce from 500 to 200. So in this type of question you can apply this question, this equation. As you know, P1 V1 is equal P2 V2. So initially P1 means the initial pressure, it was 1 bar. What is the initial volume? 500 liter. Now what pressure you have to apply, you have to find out, and what volume you have to make, you have to make it 200 liter. So ultimately you can find out the amount of pressure, how much you have to apply. It will be 500 divided by 200. So liter automatically cancel, unit you will get bar. 0 0 0 0 cancel, I mean you will get 5 by 2 bar. 5 by 2 bar means you can write 2.5 bar. So this equation is applied in this type of question. If you want to compress some gases, then you have to apply some amount of pressure, and how much pressure you have to apply to compress the gas, that you can find out by applying this equation. Thank you.